Assalamu alaikum. Welcome to my channel Tech Talk with Shahid. My today's topic is how to calculate bolts for movement connection. In last vlog, we calculate bolt calculations for pinned connection, but now we will discuss for movement connection. First of all, we will draw one sketch for movement connection. This is our column with flanges. Then we have end plate. This is our beam. Suppose we have a bolt here. We have bolt here, small stiffener, something like this. So this is our moment connection. Now we will put some forces here for easy calculations. We will add axial force, we will add shear force, then we will add moment forces also. Like last time we consider 50 kilonewton axial force, 100 kilonewton our vertical force. We will consider the same, so it will give like a continuity. This is our 50 kilonewton fx, and fy vertical shear is 100 kilonewton. Then clockwise movement we will add, suppose 20 kilonewton meter. So with this graphical representation we can get idea like this vertical shear fy, this will give shear to these bolts, and it's our axial force. When there will be axial force, so it will add tension force on this bolt, not shear like we consider in our pinned connection. Because in pinned connection, either it's axial or vertical, it was giving like a shear force, so that's why we take resultant. But now fy will give shear on this bolt, and fx will create tension on this bolt, so we need to tackle separately both. And now we will see from this moment, either it will give like a shear or axial force. So with this orientation we can get idea, it will create pull and push, because this moment it will be on this member. So when there will be moment on this, so there will be push on the pull on this side, and there will be push on this bottom flange. So it will give pull and push on this member. So due to this you can get idea, it will give tension force or compression force on these bolts. So when there will be moment here, so there will be tension here and compression here. But if it will be reverse, so in that case there will be tension here and compression here. So as per our moment orientation, we can get idea this movement will create tension force and compression force. Since compression is not critical, so we need to consider tension force. From this we can get idea like tension force, it will come from fx divided by number of bolt. So total our number of bolt will be 2 plus 2 is equal to 4 m20. What we can consider, 2 will be here, 2 will be here, so total will be 4 bolt. So fx divided by 4 plus tension force from movement. So this will be our total tension, and our total shear force will be fy divided by 4. So from these two we can calculate our number of bolts of whatever we choose here, either it's correct or not. Okay, first of all, we will calculate from tension force from Fx is equal to 50 divided by 4 is equal to 12.5 kilonewton. Okay, now we need to see how much tension per bolt we will get it from moment. So tension from moment, it will be 20 divided by, because this moment, this pull and push will depend on this bolt. So in actual, this pull and push will be depending on bolt locations, because this member is connected with this column via these bolts. So when there will be pull and push, it will be on these bolts like this. If this is our tension, then here will be compression. So pull and push depends on this distance. Suppose this distance is 300, because it depends on how much is our this member size, and 50 or 60 we need to provide here, 50 60 here. So we consider here 300 for example for our calculation. So this will be 0.3 because we need to calculate moment in kilonewton meter. So 300 divided by 1000, we will consider here 20. So we need to see 20 divided by 3. So 66.67 kilonewton will be at this point as a tension, and same will be here for compression. And now we can see, so this tension force, we need, this will be tackled by this number of bolt, because when there will be tension here, so this bolt will not contribute, only this bolt will contribute for this tension. So for this we need to see how many bolts we provide here. Here we have 2 bolts, so 66.67 divided by 2 divided by 2, so 33.33 kilonewton per bolt. So this and this, when we will add, total force, it will be 12.5 plus 33.3 is equal to 33.3 plus 12.5 is equal to 45.83 kilonewton. So this is our maximum tension force which will come on one bolt. Now we need to calculate shear force. So this will be, our shear force is 100 divided by how much, because this shear will be taken by these bolts and these bolts as well. So total are 4. So here will be 25 kilonewton as a shear force. So now we by this calculation we calculate maximum tension per bolt and maximum shear per bolt. So now we need to see how much is shear capacity and how much is the tension capacity of M20 bolt. Our shear capacity like we discussed last time, this will be calculated by shear strength multiplied by effective area of bolt, 250. So 250 multiplied by 375, 93.75 kilonewton, it's a shear capacity. and our actual share is 25, so it's greater than 25 actual kilonewton. So okay, so this bolt, till now we see our capacity of bolt is in share is 93.75 and actual share is 25. So now this is okay, so we are safe in share side. Now we will see how much is bolt capacity in tension and how much is our actual. So tension capacity we can calculate. Here is 10 tension strength of bolt is 560. So 560 is tension strength of bolt multiplied by area. Then again we need to multiply by 0.8. So then we will get its strength in tension. So which is 112. Mostly considered 110. So 110 is greater than our actual total tension force 45.83. So our bolt is okay in tension also. So like this we can calculate any moment connection for whatever will be forces. So it's a very easy way. At least you can get number of bolt, or if you choose one connection you can calculate by yourself either whatever you bolts you consider, either it's satisfying your criteria, design criteria or not. Hopefully this calculation is very informative for you guys. Please like our channel, share it, comment it. So in future we will come back with new calculations, new tricks. If you need anything to add in our coming vlogs, so comment it, we will try to include. Thank you so much.